Hi. So we have another problem in our problem solving series. These are problems geared towards JEE Advanced 2024, and I hope the series is useful for everyone. So today's problem is a matrix problem. Again, we have any 3 cross 3 matrix M, and let I be a 3 cross 3 identity matrix. Then there are two new matrices defined E and F, which are 3 cross 3 in size, such that I minus EF is invertible. Okay. And if it is invertible, we are saying G is the inverse of I minus EF. Then we have to check these statements. The first statement is det of FE is equal to det of I minus FE, det of FG. And similarly, there are four statements, right? Okay, so let's see how we think about it and how we proceed with such a problem. So first of all, we know that this is invertible and G is equal to this, I minus EF. So we can first of all say that det of I minus EF should not be equal to 0, right? Because it is invertible, its det cannot be 0. And we have G inverse is equal to, or G is equal to I minus EF inverse, I minus EF inverse. Therefore, G inverse will be equal to inverse of an inverse is itself, so I minus EF, right? Great. So we know G inverse, we know G, and now we can say that because of the property of inverse, we can say that G multiplied by G inverse will be equal to I, and also G inverse multiplied by G is also equal to I. This is a standard property of any invertible matrix, right? So here what we will say is we'll put G inverse as I minus EF. So this becomes G into I minus EF is equal to I. And this side will say G inverse is what? G inverse was I minus EF, right? Again, we are putting for G inverse, we are putting I minus EF into G, right? So if you multiply this out, you'll get GI is G only, and this is minus GEF is equal to I is equal to this is GI is G minus EFG, right? So can you see from the first and the third inequality that it is obvious that GEF is equal to EFG, right? So immediately that gives us the third option as correct, right? And we also get things like, we know what is G minus I. G minus I is equal to EF. This is coming from where? This is coming from this equality, right? So what have we done so far? We have used the fact that G is invertible, and we will use the identity that G into G inverse or G inverse into G are both equal to I. And from there we get that GEF is equal to EFG, right? But we have to check the other options as well here, right? So how do I check the other options here? Let's try and check the second option. This option I want to see whether it is true or not. I have these results. I have GEF is equal to EFG. I also have G minus I is EFG, right? So I will try and do this on the next screen. So just follow along. So what I have to check is det of I minus FE multiplied by I plus FGE. I plus FGE is equal to I. And what have I figured out so far? I figured out that GEF is equal to EFG. And also I have understood that G minus I is equal to EFG. This comes from the equality that we saw earlier, right? So if I want to find this out, notice that this is a pure number. This is the determinant, where this is a matrix and this is a matrix, right? So let me just first try and figure out what is the product of these matrices, right? I minus FE into I plus FG. Maybe if I know the product of these, I will be able to take det of that. And when I do det, I will get at least this term I will get, right? So looking from the option, we are trying to evaluate this product of matrices, right? So this will become I plus FGE minus FE, and then it becomes minus FE, GE, right? Correct. Now, if you notice here, this part, EFG here, can be written as G minus I from here, right? So we can write this as I plus FGE minus FE minus F into G minus I into E. And if I simplify this a little, this is GE minus E multiplied by F like this. So this is minus FGE plus FE. And there was a minus Fe here, and there was a plus FGE here, and a plus I here, right? So if you see, plus FGE gets cancelled with this, and minus Fe gets cancelled with this, we are simply getting that this is equal to I, right? After simplification and using this property, we are getting this is equal to I, which implies that if I take det of I minus FGFE, right? And it will become det of I plus FGE, correct? That should be det of I, which is 1. And therefore, you will get a relation something like this, not a relation like this, right? This relation implies that a scalar times this matrix is equal to I. But what we are getting here is the product of this and this is equal to I, not the det of this into the product into this matrix, right? So what we see from here is that option 2 is incorrect. Option 2 is incorrect. This was my option 2, right? That is not correct. Okay. Now, if option 2 is incorrect, can we see option 4? Option 4 talks about I minus Fe multiplied by I minus FGE is equal to I. Now, this option is also incorrect because we have I minus Fe into I plus FGE is equal to I. So the correct relation is this, whereas option 4 has a change of sign here. So this is also wrong. You could also confirm it by multiplying it out here and seeing how it simplifies using these properties, right? So option 4 is also incorrect. 2 is also incorrect. 3 is correct. And then we have to look at the option A, right? So let's think about option A. So I'll just write it on the next screen here. Option A talks about we have to verify that det of Fe is equal to det of I minus Fe multiplied by the det of FGE. Okay, in order to verify this, obviously I will need to evaluate the product of this stuff, right? So what I can say is, like, if Fe was equal to I minus Fe multiplied by FGE, right? Then obviously when I take that on both sides, this would have come, right? So let me just evaluate this part here, right? So we'll say I minus Fe multiplied by FGE will become FGE minus FEFGE, right? And here again, EFG I will write as G minus I, right? So FGE is equal to minus F G minus I into E. So what are we getting here? GE minus E multiplied by minus F, and this is FGE. And this becomes FGE minus FGE plus FE, right? FGE minus FGE plus FE. So what we are getting is that this is equal to FE, right? So we have gotten the result that this is equal to Fe. So obviously, if I take det on both sides, Fe will be equal to det of I minus Fe multiplied by the det of FGE. So option 1 is also correct. Option 1 is correct. Option 3 was correct. Option 2 and option 4 were incorrect. And you understand how we are utilizing the fact that G was invertible. What we did initially was the crucial step of the problem where we said G inverse was equal to basically I minus EF. And then we said that G into G inverse is equal to I is equal to G inverse into G. and then we replaced G inverse as I minus EF everywhere, and we got nice results from there, right? So I hope this teaches you something, and you will be able to tackle similar problems in the future yourself. Um, we'll continue with more problems in this series of JEE advanced problem solving. I'm also planning to bring out certain other videos with slightly advanced topics so that you can increase your mathematical abilities. Uh, Please remember that there is a doubt sharing link in the description of each video. You can use that Google form to upload any problems that you find difficult, any mathematical issues or physics issues that you have. Please feel free to use that option, and I will try and solve it as soon as possible for you. If you like the video and the content, please subscribe to the channel, like the video, and stay tuned for more. That's all for now. I'll see you in the next video.